Welcome. In this video I'm going to show you how you can determine effect sizes after a post-hoc analysis from a goodness of fit test using Python. I'm currently running Python version 3.12 and in this video I'll be using my own stikpetP library. So after a goodness of fit test, you probably performed a post-hoc analysis if it was significant, and then depending on which test you used for that, you could either use Cohen's G, Cohen's H2, the alternative ratio if it was like a binary test, or if you've used a goodness of fit test, then Kramer's V, Cohen's W, Johnston, Berry, Mika E, or Fay. And if a z-test was used, then perhaps the Rosenthal correlation coefficient. I have separate videos for each of these measures by itself. And in this video I'm just going to show you how you can actually do this for all the results from the post-hoc analysis. I'll need some example data, so I'll load in pandas. So I can load in this GSS, General Social Survey from 2012, adjusted for some example purposes. I actually don't need all of its data, I just need one nominal field, so I'll be using as a nominal field the mar1 field, and that's the marital status. And to give you a quick impression, I'll use the value counts, so you can see the frequencies, and for example 79 people indicated to be separated. Now my stikpetP library is actually available via pip install and then the full link to this file on my GitHub account. So it's not available via just pip install. You need the full link. Once it's actually installed, you can import it like any other library, and the function of interest is actually now this ES, short for effect sizes, post-hoc goodness-of-fit. It actually takes as input only the data itself, the post-hoc results. So we actually need those. So I'm going to be using my own function that can generate those. I have a separate video where I go over some more details for that one. And after that, you can say which effect size you want to use. And if it's one where if you're using Kramer's V, you can even opt to use the Bergsma correction. So here are those post-hoc results, and now I can actually feed that into my ES post-hoc goodness of fit. And as you can see, for every possible combination pair and every possible test that was run in the post-hoc, we now also have the Cohen H value. You could then actually use TH, thumb rules, post-hoc goodness of fit, that asks for that effect sizes, if you want to convert it from one to another. And if you are using JPM, E or Fay, then you should also submit the post-hoc results. And most commonly the quarks are just the qualification that you want to use. As mentioned earlier, I have separate videos where I go over the details of each effect size measure by itself. So here I'm just going to show you how you can apply it to this post-hoc result. I feed it the result we had just now. Let's say I wanted the conversion to be true. And as you can see, it gives the same result as earlier, but now it also converted it, so it shows the conversion value. And then a qualification according to whom. So in this case, according to Cohen, 1988, page 198, we could qualify this as medium, this Cohen H of 0.43. Here's just another example where I use a residual goodness of fit test. That is just about the categories itself versus all others. Again, I can use the ES post-hoc goodness of fit, for example, to get JBM E. And if I wanted to see some rule of thumb for that, that one does require to also feed it the post-hoc results because it actually needs that minimum expected count, and that should give you the final result. Alright, I hope this video was helpful and thank you for watching.